We're going to be discussing empirical formulas today. Empirical formulas are going to be the most simplified form of a chemical formula, and they are going to be found utilizing percent compositions. For empirical formulas, it's going to be my subscripts after they have been simplified, and that is what everything is going to look like. So it's not going to be quite correct, but it will be in proper proportion. So we have some steps to find the empirical formula. My very first step is going to be converting my percent to mass. My steps I kind of state almost in like a little bit of a rhyme, and that way it's a little bit easier to remember. So I have percent to mass, and I'm going to be assuming a 100 gram sample. Then I will do mass to mole. I'm going to be dividing each mass of each individual element by their atomic mass from the periodic table. Then I will divide by small. I'm going to divide each of the products from step 2 by the smallest product from step 2. And then finally, I will go ahead and multiply till I have whole numbers, or multiply till whole. All of the numbers that I got out of step 3, if they are not quite close enough so that I can round them to a whole number, I am going to go ahead and multiply everything by this same number until I can assure that all of my subscripts will be whole numbers. And then I will attach my whole numbers that I just got, and I will make them actual subscripts. So I'm going to go ahead and get started. So we are going to be finding the empirical formula for a compound that contains 40.0% carbon, 6.7% hydrogen, and 53.3% oxygen. What I like to do first is go ahead and write out all of the compounds, and that way I can keep them in table format, and they are all going to be within the same column, so I don't end up getting them mixed up or anything like that. So my very first thing I'm going to do is I'm going to take their initial percentages, and then I'm going to convert them into grams. Now, key point here was that I am assuming a 100 gram sample. Since I'm assuming a 100 gram sample, that means that 40.0% of 100 is 40.0. So all I have to do is change the percent sign to grams, and that will be my very first step. That's the percent to mass. All I did was drop the percent, and then I am left with grams. Then I can move on to the mass to mole, where I'm dividing each of these new masses by their atomic mass. So I have gone ahead and done that. So carbon's mass on the periodic table is 12.011. Hydrogen is 1.008, and oxygen is 15.999. I'm going to be dividing all three of these, and then I will write down every single number that comes out of my calculator. It is very important that at this step you do not round. A lot of times, especially if you see C, H, and O combined, or any sort of organic compound, if you drop numbers here, you will be very, very sad because you're going to end up getting the wrong answer, and then you will have to redo the entire problem just because you were too lazy to write down every number. So be super careful here. This is not the place to round, not the place to get lazy. I'm going to go ahead and move on to step 3, which was to divide by my smallest number. As I look between these two, they look pretty similar, but this one is, since this one was ever so slightly smaller, I'm going to divide by this one. So I'm going to go ahead and I'm going to be ever so careful to write out every single number that matches this, and then I'm going to plug it into the calculator. Whenever I plugged it into the calculator, I got the numbers 1, 2, and 1. This was obviously 1 since I'm dividing by the exact same thing. This one was going to be close enough to 1 since we had my issues way out in my decimals. Same thing with hydrogen, issues being way out in my decimals. So 2 is going to be close enough. Since these are nice enough numbers, I don't need to multiply to a whole because they're already whole numbers, which means I can go ahead and just establish them as my subscripts. C1, H2, O1, and that's it.